Hello, my dear students, how are you? Today I am giving you a very interesting lecture about lab preparation and manufacture of ammonia by Haber process. That is very important for examination viewpoint. Yes. So today is lab preparation and manufacture of ammonia by Haber process. Yes. So at first we have to know some general idea about the ammonia. Its molecular EMF means molecular formula is NH3. Molecular weight is 14 plus 3, how much? 17. And when you talk about the vapor density, so always keep in mind molecular weight by 2. So how much we have? 17 by 2, 8.5. So what we have? 8.5. That is about the general knowledge of ammonia. So at first we are talking about lab preparation of ammonia gas. So its principle is like this. When the paste of slacked lime and sal ammoniac heated ammonia gas is produced, which is collected in gas jar by downward displacement air. Why? Because ammonia is lighter than air. So vapor density of air is density of air is 14.2, about we can say about 14.2. But when you talk about the ammonia, what you see? Vapor density of ammonia is how much? 8.5. Yes. So reaction is like this. Reaction involved. So slacked lime, COH, calcium hydroxide is known as slacked lime. That is the common name. Its chemical name is calcium hydroxide when heated with ammonium chloride, that is what you see, sal ammoniac, and what is chemical name is ammonium chloride. What we have? Ammonium. Ammonium chloride when heated. So what we have? Calcium chloride H2O plus NH3. So what we have? When balanced, what we have? 2H2O, 2NH3. So always we have to balance by heat and trial method. So for this we need practice. I have already talked you in balancing of chemical question by heat and trial method and partial method. So many methods I have taught you. Now next one is suitable dehydrating reagent. Sometimes ask you what are the suitable dehydrating reagent for ammonia gas. So many. So suppose Kong sulfuric acid. So when you talk about what you see, Kong sulfuric acid. Kong means concentrated. When it is used, so what is it? That is acid, that is base. So reaction, just addition takes place. Ammonium sulfate. How many ammonia? 2. So multiply over 2 there. That is ammonium sulfate. Yes. Likewise, second one is what you see, phosphorus pentaoxide, what you see, NH3 plus H2O. So what you see, ammonium, that is ammonium phosphate. So balance use, what you see, 6NH3, 2 ammonium, 3 phosphate, 2. So what you say, this is the balance chemical equation. Like this, when you talk third dehydrating agent is what you see, fused calcium chloride. Fused means melted, molten you can say, fused. Calcium chloride is also used as dehydrating agent plus NH3. What you get? Complex compound 8. That is the complex compound. So how many? 8. Fourth one is quicklime, CO, quicklime. So when that is treated with ammonia, so what you get? No reaction. Why? Because calcium oxide is also base, ammonia is also base. So in this case, no reaction. So what we are observing over here? So when you use Kong sulfuric acid as a dehydrating agent means to absorb moisture, Yes. So when we talk about the Kong sulfuric acid react to each other, and what we had? Ammonium sulfate. Likewise, phosphorus pentaoxide. So what we get? Ammonium phosphate. Like fused calcium chloride, what you get? Complex compound, calcium chloride having 8 molecules of ammonia. See, all the 3 dehydrating reagents react to what you see, ammonia, and what you get? Different type of product. But fourth one is quicklime. When react with ammonia, there is no reaction. So, what is the suitable dehydrating reagent? So, answer of this question is suitable dehydrating reagent for ammonia gas is quicklime. So, we have clear. Yes. So, that is about what you see. Lab preparation also you know. Next one is what are the suitable dehydrating agents asked in examination. So, what the suitable answer? Quicklime, because all the three sulfuric acid, phosphorus pentoxide and fused calcium chloride react to ammonia and what we get different type of products. See, if they react, never suitable. So, what the suitable reagent over here? Quicklime. Why? Because it does not react with ammonia. Yes, quicklime because it does not react with ammonia. So, I think you have clear which one is suitable and why. So, always in science we have to ask the question why. Next one is manufacture. That is very, very important. Manufacture of ammonia on large scale by what you see Haber, name of the chemist, Haber's method. So that is very, very important. Always ask in examination. So at first we have to know what is the principle of this one. So what you see, when the mixture of one volume of pure and dry nitrogen and 3 volume of pure and dry hydrogen is passed over, heated, finally means powder form, finally divided, iron catalyst at 450 degrees centigrade to 500 degrees centigrade, 200 to 500 atmospheric pressure. 1 atmospheric pressure is what you see 760 millimeter of Hg. Pressure in presence of molybdenum is your metal as promoter what is ammonia is obtained which is further condense with cold water liquid ammonia in liquid state, liquid ammonia is obtained. So reaction is like this. So what to see, nitrogen, 3 molecule of hydrogen, reaction is what to see, reversible. Sorry. So that forward reaction, that is the backward reaction. So that is known as, and what you get, 2 ammonia, and how much, 22 kilocalorie per mole. Here the value of K, T is what you see here, the value of Q is what you see, 22.4 kilocalorie per mole. Yes. So that is reversible sign. That is reversible sign. That is the rate of forward reaction, that is the backward reaction. Yes. So what type of reaction it is? It is what you see, this reaction is reversible and exothermic. Exothermic means, what do you mean by exothermic? So exothermic means release of temperatures. Always keep in mind, exothermic reaction. So in this case, Le Chatelier, name of the chemist, Le Chatelier's principle is applied. So according to Le Chatelier's principle, for high yield of ammonia, high yield of ammonia is favored, better to say, ammonia is favored by, favored by first low temperature, second one is high pressure, third one is high concentration, and fourth one is use of iron as catalyst and molybdenum as promoter. So new term, promoters. So what we have, so when we talk about the promoter, so what we have, promoter, can say it is the chemical, better to say the chemical substance which increases the activity of catalyst is known as promoter. For example, molybdenum in this reaction acts as promoter. So I think you have clear what is promoter. The chemical substance which increases the activity of catalyst is known as promoter. So in this case, example is what we see, molybdenum. Now we have to see the criteria generally asked in examination, principal, criteria and flow chart. So what we have, next heading is criteria for high yield. Yield means product of ammonia by Haber process. Yes. So at first we have to know the reaction, nature of reaction. Nitrogen plus 3 hydrogen is what you see, reversible reaction. What to get, ammonia. And how much energy released over here? 22 kilocalorie per mole. For the formation of 1 mole, it releases how much energy? Heat energy 22.4 liter. 4 kilocalorie per mole, you can say. So first one is effect of temperature. So this reaction is exothermic. It means already liberates what's heat energy. So in this case, we can increase the temperature or decrease the temperature. No any effect of temperature over here. So what we see, that is exothermic reaction. So what we have to do, low temperature is favorable for this reaction because what the reason? Because it is an exothermic reaction. Yes. Sometimes I ask you, so when you increase the temperature, what happens over here? So what's your answer? So if we increase the temperature more than 450 to 500, so increase the temperature, it increases rate of backward, that is the backward, that is the forward, and that is the backward. We know the rate of forward reaction, it means we get low yield of ammonia. Yes, first fact, what is the effect of temperature? Second one is effect of pressure. So what we have to see? Volume. So in this case, nitrogen is 1 volume, hydrogen is 3 volume, ammonia is what you see 2 volumes. So what you see over here? See, reactant side is 4th volume, but right hand side what you get? Only 2 volumes. What you see over here? So in this case, what we see, volume is decreasing. So according to Boyle's law, what we have to do to maintain this equilibrium? Increase the pressure. Yes. So effect of pressure. So in this case, so increase of pressure. Pressure is favorable for pressure is favorable for this reaction. Why? Because the volume of product is decreasing with respect to volume of reactants. Yes, what the reason? So volume of product is decreasing with respect to volume of what you see reactants. Now third condition is what you say effect of concentration. Effect of concentration, or we can say amount. It's what's practical. So when we increase the concentration amount of the left hand side, so what do you see? There is increasement in the concentration of product. It means what we can say, the concentration or amount, we can say the concentration of product is directly proportional to concentration of reactant. It means higher the concentration of reactants, higher will be the product, and vice versa, just reverse, vice versa. So we are clear. So if we increase, according to this, if we increase the concentration of what is a reactant, the concentration of product what is automatically increases. If we decrease the concentration, what we see, concentration of product also decreases. So when talk about the effect of concentration, directly proportional to concentration of reactant. Yes, so I think you have clear. Now fourth one is what's the use of iron catalyst and molybdenum as promoter. You know about the promoter. So, use of iron catalyst and molybdenum as a promoter increases the rate of the reaction. It means we get high yield of what you see ammonia. So what we see in this case, criteria means condition. What the condition necessary for getting what you see high yield of ammonia. So in this case, this reaction is what you see reversible as well as exothermic reaction. So in this case, suitable condition is low temperature, high pressure. Why high pressure? The volume of product is decreasing. Third one is effect of high increase of concentration of reactant, also increases the concentration of product. Fourth one is use of catalyst, iron catalyst and molybdenum as a promoter. Increase the rate of the reaction, it means we get high yield of ammonia. So for getting high yield of ammonia, you have to follow 4 these conditions. Yes. So that is about the criteria for a chemical equation. Yes. Now they is not asking you what to say, write down the word say diagram, figure and describe. So in this case we have to ask what is the flow sheet diagram. So flow sheet diagram for ammonia gas by Haber process. Very, very important. Yes. So in this case, so what is what we need raw material? Nitrogen, pure and dry. How much? 1 volume. Generally produced by from air. It is produced by air. Yes. Next one is hydrogen, which is also pure and dry. How much we need? 3 volume. So main resources of hydrogen is what we see from natural gas. Natural gas, we know about methane, what do you say, butane, C4H10, butane, etc. Yes, and from Bosch is the Bosch process. Yes, so there are 2 resources by which can get hydrogen. First one is natural gas from methane, butane like this, and from Bosch name of the chemist, Bosch process, but we can also get more and more what to say hydrogen. Yes. So now, so what you see, that is the mixture chamber. Mixture chamber. So what you see, nitrogen and hydrogen in the ratio of what you see 1:3. Yes. Then what you see, regulator. This is regulator. Regulator, you can say pump. Goes to what is a catalyst chamber. Catalyst chamber, where what we have? Iron, Fe, catalyst, molybdenum as promoter, temperature is maintained what you see 450 degrees centigrade to 5 degrees centigrade, 200 to 500 atmospheric, 5 that is pressure. So in this case we get about, in one cycle we get about 10 to 15% ammonia only. So you have to keep in mind. So one cycle we get about, this is the sign of about 10 to 15% ammonia only. So now what we have to do? Cooling with what you see? Cold water. So cold water contains only ammonia. So in this case ammonia, so it's better to say cooling chamber. Here ammonia converts into a liquid ammonia. Yes, that is the what you see. So that is collected in a storage. So what we have? Liquid ammonia. Yes, that is the storage. You can say storage. Now the unreacted nitrogen and hydrogen, which is about how much? 85 to 90% is collected and passed into, that is the regulator mainstream. Yes, so that is recirculating pipe. So what we observe? So again from starting. So for this, at first we take nitrogen, which must be pure and dry, 1 volume. That is the 1 volume from air. Generally it is isolated by fractional distillation of air. Next one is hydrogen, pure and dry gas, 3 volume. Generally extracted from natural gas, maybe methane, maybe butane, and from Bosch process. Bosch, the name of the chemist. So that mixture is collected in mixture chamber. Here nitrogen and hydrogen is 1:3 volume. Yes. So now this mixture is passed into what is a catalyst chamber, but we have to pass in limited amount. We have to know the capacity of the catalyst chamber, how much we have. So according to capacity of the catalyst chamber, we have to pass the mixture of nitrogen and hydrogen, and that is the regulator pump. We have to pass. So in regulator condition, so all condition are iron catalyst, molybdenum as promoter, 450 to 500, 200 to 500 atmospheric pressure. So we get about 10 to 15% ammonia in one cycle. Now this is cooling with cold water. That's the cooling chamber. Here ammonia converts into liquid ammonia, yes, and that is collected in storage, yes. Now what is the unreacted nitrogen hydrogen, which is about 85 to 90%, is what you see with the help of recirculating pipe have passed into the same main stream. So by this cycle and this cycle, so what you see, this is the cyclic method, and by cyclic method we get more and more what you see, ammonia, yes. So thank you for watching this video. So that's very important. So have a nice day. Be bona fide in what you see chemistry like silica, yes.